So it includes like things like list of everybody who's in the party, okay? Where are you going? Who's the emergency contact that's not with you? And then there will be a person who is the communications point person. So somebody at least would have an in-reach for satellite text messaging, because we're going to be in a place, actually we're pretty much out of cell coverage here, right? At Patuxent, but seriously, when you're on the north slope of Alaska, you want to have some way of getting information out. So there'd be a communications primary person. I would go through with everybody else on the team how this thing works, how to turn it on, how to set off the alarm. So if I'm incapacitated, then somebody else can use it. We would have a health response, a first aid or first responder identified. And as we introduced ourselves, we would soon find out that Caitlin has the highest level of medical training among the group. And she has the very complete first aid kit that's way beyond. So if somebody is, has been by a bear or, whatever, I'm serious. She has the tourniquet and the bleed stop kit and everything like that. And then we would know, maybe that Liz and I are, have the second level of medical training. So if Caitlin is incapacitated, then we're prepared to, to do that sort of thing. One of the really important things is the driving. So one of the things we always check is, Caitlin, you drove the Suburban, up the Hall Road with this team in it. Where are the keys?
I left them in the Suburban.
So she would have the spot in her back where the keys are, but other people will know where that is. And then you also have a person identified like Liz as second in command if Caitlin is incapacitated, but Liz knows how to drive a Suburban on the Hall Road. She knows all of the safety procedures and the CB radio calls and everything like that. So, but we have that kind of documented out and just fill it in with a field pencil or something like that, and we'll send the link around to that form. So, any questions or comments about that? Or Liz, do you want to add anything as a like the high points? Okay.
I got a question.
Yeah.
Would you bring a second one just for redundancies?
Absolutely.
Yeah.
One is none and two is few.
There you go. Cool.
So we would have at least two of these and at least two complete first aid kits.
Excellent. So we're going to use the ASD and the STELLA to take a look at pigments.
ASD, but I'm not like set on ASD, whatever.
Okay.
And so the goal is to, so instruments, we need STELLA. Which STELLA are we going to use?
I want to use a 1.2 and a Q2.
Okay, so we have those two. So ASD and so chlorophyll meter, I'll say.
Okay, so chlorophyll meters. Okay.
Ideally, we want to measure leaf area.
Leaf area? Okay, so LAF?
Yeah, but how do we do that?
I don't know.
I mean, we do have the instruments, but this is measured early in the morning, late in the evening, or... okay, so let's see. Here I'll put it TBD, LAI. Okay, so this is like measurements, instruments. And so people, who is going to measure with STELLA?
I want to...
Who is the STELLA operator?
Well, I could bring one. I wanted to bring some other people. We needed to settle on the date, so I did notify them that we were looking at Friday. And so I was hoping that Rachel Stagner.
So you can do Friday, but Friday will be very hot. Ideally, if we are good with our instruments, we should be able to get done in 2 hours.
Cool.
And ideally that will be like in our favor because it will get hot. But we don't know. And so do we need to meet here in the lab to pick instruments, or we will just meet directly in the field?
I can get all of the ASD instrumentation set up on Thursday or
Okay.
Wednesday, but I do not have an understanding of your gas exchange.
We're not doing gas exchange.
The chlorophyll.
The chlorophyll, I have it, I'm charging it right now. I can have it by the end of the day ready. So, yes, gas exchange sounds good, but we're not prepared for that. And that takes longer. So maybe next time. But now I will set up the chlorophyll meters and I'll think of LAI. Mike will set up the STELLAs.
Yep.
And prepare them. Jesse will set up the ASD and the panels.
Okay.
And tripods. Do you have tripods, Jesse, to bring for the panel?
There will be a panel tripod, yes.
Okay. And so then let's meet directly at OP at 9.
Okay.
Does it sound good?
That sounds good to me.
Okay. I'll go earlier, like on Wednesday or on Thursday to the site, and I'll mark the 5 sites with flags.
Cool.
And there, if I can separate 3 points, like so we measure the same 3, and there will be like 1, 2, 3, so 1 with 1, and so we can still assemble the data in some way.
Sounds good to
But
me.
there will be a lot of panel measurements, so
Oh, yeah.
you have to be very prepared.
Oh yeah.
Okay.
The panel measurement sandwich.
Okay, yeah. And so this is it. This is.
And why do we do the panel measurement sandwich? Why do we go from like
Because
calibration
STELLA
measurement to
records
the
digital
same?
numbers. Because STELLA, I was told by Paul that it's a radiance already. It's not digital numbers.
Yeah. Well, it is a radiance, and then he does have the counts on there now for the
Okay.
1.2.
But still, we do that because we want to convert to reflectance. And we don't have a way of getting other way reflectance. Reflectance is a ratio between the panel measurement and the measurement from the target.
And why do we do it like multiple times? Why do we got to keep going
Because
back and
the
forth?
sun is changing, the clouds are flying, because the time is passing. Like at 9, the sun is here, but at 9:30 there, and then moves up, and so because of all of these changes.
Excellent.
So we need to know what is the incoming solar radiation at the time of the measurement. So because of that, if you take too long to take a measurement after the panel, you just better go and take another panel.
So we have our goals, the instruments we're going to take, and the people that are going and what they're going to be doing, their roles.
Yes.
If you were doing a longer campaign, what else would you be preparing?
Food and water. And everybody comes with covered toes, like no sandals and flip-flops.
Yes.
Oh, I have had a student with shorts and flip-flops, and the ticks, of course, there. So the socks need to be put on top of the pants, so the ticks climb up, and then when you go home, you check carefully and remove everything. Yeah. Hats. You need hat, water, sunscreen. The list.
How many field campaigns have you been on?
So, I mean, I'm a forester by background, and so, I don't know. I have started in college, and then since then I have done different ones. For some time I worked for the Ministry of Environmental Protection, and I was surveying protected areas. And so there I was just going to different protected areas and looking at the plants, the animals, the everything. But that's when I was very young. Then this was in Bulgaria, and then I did my dissertation in the Czech Republic, and there we just did surveys of the woods for forest health. So there is a manual that is for forest health, and you go with it, and you do the survey, and you measure this kind of things, like the chlorophyll, the height. We should measure plant height also, yeah. To know, because they may get taller or shorter, and makes a difference. I have a doctorate in remote sensing for environmental applications. I teach like at University of Maryland, Baltimore County, and I do research here at NASA Goddard, and I do vegetation function and health. And that's like what makes me happy and it drives me excited, right? And I'm engineer by background. Okay, I can. So I can. Here 78 degrees. That's not right. There should be more like 90 something, right? 81. See, it's changing.
You say you have an engineering.
Forestry is an engineering field.
Okay.
So I know, like we study roads, how to build roads, how to measure, of course, plants and things. That's what I like the best. But we studied also the animals, like how to take care of them. Okay, so this is 90 degrees. Okay.
What makes a good spot to measure?
We want a representative of the field. Like, look at the field out there. We want to measure spots that represent the field. And like, for example, if you turn to the other field, you see that it's nothing like this field. Mm-hmm. They're very different. And so we'll measure 3 repetitions here, because see, some are denser, some are not. Some have more soil cover, that's all. Okay. Then I picked another patch, like this patch. And so here, like 1 spot, 2 spots, 3 spots.
Okay. And why are we taking 3 measurements at each spot?
3, because I was thinking that if we have 3 measurements at each spot, if some are not good and representative, we can get rid of them.
Okay.
Does it make sense?
Yep.
And here, but you see, we're measuring basically the same. And so here is the patch, and so this patch has less soil, I don't know, less cover. And is that representative? It's hard to know. But like this is 1, 2, and 3, like that. And then the other and the last one. And so here I was thinking to measure in the middle, like that. And so 1, 2, and 3.
Okay. All right, and there's the last one for this grouping. And these are soybeans, correct?
These are soybeans.
Okay.
So 1, 2, and 3. And that's it. This is the soybean.
Okay.
And so 1, 2, and 3.
Okay.
Then we'll go further. And this is already very different. And so maybe like here.
Okay. And why is it different again?
I mean, they throw nitrogen on it, like they fertilize it, and 100. So this field is very well studied. They know what is optimal for this soil and this water and this amount of natural nitrogen in the soil. What is optimal for the corn to grow? And so they do treatments of 0, 25, 50, 100, and I don't know if they do 150 anymore. Before they did that.
150 what?
Nitrogen.
Oh, nitrogen. Okay.
So 100 is the optimal. So this maybe, to me, looks like 150 because it's very tall. Mm-hmm. So anyway, we want to measure like here with the pole and the STELLA. Mm-hmm. And so how are you going to measure with the STELLA here?
We have poles we can put 'em on. And then so for over there for that smaller corn, why are we measuring over there again?
Because the nitrogen is low. See how they're yellowish, and it's kind of off the track where they have spread a lot of fertilizer. See how they burn on the edges. I don't know what causes that. I mean, obviously low water. But
It's causing the burning over here on the edges of the leaves.
and it continues further, so
Okay.
we'll have some more. So this will be like 3.
3 right here.
I mean, like 1 is on the right, 2 is in the middle, and 3 will be on the left.
Okay. So this will be the 6th site. So we drew in 6 over here in the corn.
Yeah.
Okay. Fantastic.
Okay, so that's it.
And so how many years have you been doing these like field campaigns and taking data measurements and all that?
But see, this is what I do. This is my work. So how many years I have been working, or what?
Yeah, sure.
Well, I mean, I started in 2000 at Goddard. Before that, I was a student, and so since 2000.
Okay.
What we do is like equations for satellite products, and so the satellite that just gets zeros and ones. That's the data, digital numbers, and we need to make it into product like chlorophyll or into some other product that people want to know, like amount of water in the leaves or height of the canopy or something else, and so people need to measure on the ground and make equations to be able to derive the products and make the maps. That's how we will assemble the data.
The file.
Yes.
Okay.
So make sure Mike tells you the name, the file name that you have to put, the STELLA file name that you have to put with the ASD file name.
Okay.
Like imagine that you get both data streams and you have to put them in the same spreadsheet.
Okay.
And so the first, it will be like what you entered here.
Okay.
And we'll go from there.
If you see that I
bare bones. So.
I'm not gonna stay behind you to follow. You have to make sure.
I will.
Because I'm gonna make measurements.
So, looking at this site right here, essentially just to the right of the flags, right in the middle, just to the left of the flags.
Yeah. When you're ready, let's get started. I mean, I'm ready
We
with
still
it.
have about 17 minutes before the ASD is minimally warmed up.
Okay.
But then once that's ready, we should be able to get going immediately.
Going
Focus on
from
your donuts.
irradiance to directly to radiance is actually non-trivial. You need a distance and the field of view to do that calculation. But for DN to radiance is a simple multiplier table.
Oh,
It's
okay.
very simple. It's very nice. And that's what most people do. So that's what we'll be doing if we want to do that, because the DN on my ASD, it has a different sensor than the STELLAs do, and so the amount of photons it collects are straight up different, which is your numbers will be different. The curves should be the same because you're relative, and so that's why reflectance is always going to be the same.
Yeah, so that's the point with reflectance.
Exactly.
So we don't, the radiance is good because we can make it into reflectance.
You
The
can make it.
digital numbers are more difficult, like to
General-
compare across time and space. And
It
all.
can be. In a proper like lab setting, if you're going for reflectance, there will be no difference between using digital numbers for reflectance and using radiance for reflectance. However, out here there's a lot more variables, and radiance is a smoother graph, a smoother plot, and you can often hide some of those irregularities in the DN to reflectance multipliers. So it's pretty much what it is. do we have a direct plan of action for who does what after I take data? So my understanding is that I will be putting on the ASD, operating it, and taking data at each of these 3 plots, 3 points per plot.
No. There are 5 here in the soybean and 5 in the corn. So
6
plots?
Yeah.
Okay.
They're like about 2 meters apart, so it's not like.
Okay, but
Where
still
that's
3 points per plot.
Yes.
Cool. We are going to want to keep because before every plot, we will be putting our instruments over top of our white panel, our spectral on, to get the baseline 100% number that we're going to use for our reflectance, because we need to divide it by 100% to actually get a reflectance value. So if I go, and then you go, and then you go, but then the next time I go, then you go, then you go, the time between things is going to be different, and because the sun is rising as well, we're going to have differing values in a way that we preferably don't want. So getting the same order of operations between my instrument and the different Stellas that come after. Whoever wants to take those measurements, have fun, but making sure that the Stella order is the same.
So I think it'd probably be best if it was like people with the Q2s, and then the last would be the 1.2, because that one takes a bit longer to cycle up and cycle down and all that.
Sure.
Does that make sense to everyone?
Cool. Then what we'll attempt to do is I will be taking data on the panel, and then I will move over, take data on the first, or the 3 things. When I'm taking that first data point in the plot, the next person should be over the panel. And then when that person is over the first, the next person should be over the panel, etc., etc.
Yeah.
Do we want only 1 data point per panel on the Stellas as well?
Yeah.
Cool.
Because it will last forever. One Stella is 20 measurements.
Right. Stellas take a whole lot longer.
Let's
I forgot.
do 1. And she'll take the notes and put the data together.
Wonderful.
Yeah. And then
It's very important.
Yeah, and then Rachel has to be out of it. So.
Yeah, I gotta be
Okay,
going.
so let's go to the
Cool.
soybean first.
What time is it?
Because it's shorter.
2 minutes to go. Perfect.
You got that. I'm last in the queue.
So what are you doing, Petya?
This is the chlorophyll measurement.
Chlorophyll measurement?
Yeah.
And why are you taking that?
So we will understand if Stella can provide information relevant to chlorophyll.
Excellent. And you just,
I just took 1.
okay. So you sandwiched the leaf with the little probes at the end there?
Yeah.
Like site 1, site 2? Is that what we're doing?
Yes, it's right here on the
Okay,
flash.
S1.
Okay. What are you doing with that reference panel?
Just try to level it up.
Okay.
Perfect. Another word, when you are doing your data taking at all, do not be on this side. We do not want to shade the white panel or any of our actual things we're measuring. So,
Why do we not want to shade the white panel?
because then it's not actually a white panel. It's a white and black panel. But no, you have white panel is 100% reflective with a little bit of caveats, but essentially 100% reflective. Whereas if we have part of it in shade, that is not getting 100% of the sunlight, which is what we would be getting on the plants. Preferably, we want to have everything to be as illuminated as possible. If you look into the sky, this is actually a perfect day for it because there are no clouds, there is no real haze other than the morning haze. And so we're not gonna need to take, not gonna need to worry about the white reference nearly as badly. Oh, Labo, can you run and get the compressed air can? we will want it if there's any bugs or things on the white panel.
Yeah, I saw that.
So we want to keep our white panel clean.
Yes, without touching it, because touching and smearing smears things into the porous surface itself.
Gotcha.
And like I have sunscreen on, that'll get in there as well, and then I have to take time to sand it down and clean it.
What about donut glaze?
Don't.
Man, but it would make it smell so sweet. And
It
delicious.
would. That would attract the bugs.
Jesse,
Stop.
you're taking a reading on the white panel before every replicate?
Yes, I will be taking a reading on the white panel before every plot. Not every data point. I will be doing 3 data points after every white panel. So I'll be doing white panel,
1, 2, 3.
S11, S12.
So that one takes the longest to boot.
Jacob, which country?
So it's booting up.
Okay,
Right?
yeah.
You pressed it, yeah. So hold it up over here. Right at nadir, and it's going to take a second to boot up.
Okay.
That's why it's the biggest pain.
You don't need to press
But
the
that's
button or something?
you're doing it because you're awesome. So I appreciate it. And if you need me to take over or anything, let me know.
Sure.
Same thing with you, Rachel. Whenever you're.
Yeah, this is kind of a lot.
What about this dead board?
Yeah, you'll see. See? And that's the near
There we go.
red.
So it goes to
Side
near
of 7,
infrared,
8, 9?
it starts in near infrared and goes up to what, ultraviolet?
Was it batch number? Batch 5.
Cool.
I should go over.
Yeah, and then turn it off.
Turn it off.
Yep. And then over here, and then.
Next one?
Yeah. Did you already get the? You already got yours over there.
No,
Yeah,
no, no,
yeah,
not
yeah.
the logs here.
All right. So then, did he get his next?
I thought it was 14.
We unfortunately won't be able to do radiometric because for some reason the radiometric thing here is not sliding up. And I'm going to need to figure out. File, which is weird. I have DN, so and we're just doing reflectance, so it shouldn't matter.
Oh, you're recording the reflections directly, you're not doing gradient.
You know,
No, we want to.
That was 18. For this one, we can leave it here because our next plot is right here. But when we go to the other one, put it between 4 and 5.
I did
Yep.
Yeah.
For robotics, we did this thing with secret.
I just did see.
So I used to.
No, right about there is the center.
Don't worry. So it's 20 for the correction.
School that we were using to test them out. And when we went to the Freedom Center, which is North Mason's,
11, 12, 13.
like really close to where I used to.
You were doing the Lord's work.
And,
It's actually something that Kurt
divers
said
in the
is
water.
very important on
And
every
he's hooked up to,
thing,
like,
is to make sure nothing stays the panel.
Like,
Someone is
And nothing
always in
changed
charge of
the
the panel.
sample, you know?
and so they
What's the
people would be
point?
operating their submarine and they'd be looking at the water.
There, and now it's moved up by a fair amount. That's also why we make sure that this is level every time, because if that's level and we know the time, we can determine the angle at which we get it. Because this is a glancing blow, and this is what's called a Lambertian surface. So once you get light in, it reflects in all directions pretty evenly. A pure Lambertian surface, no matter what angle, it reflects it at all angles evenly.
Okay.
But nothing in this world is pure Lambertian. This is the closest there is. And even still, at directly sun down, you have
So everybody
more light
Yeah.
being reflected off than not.
Why are you going over top of the big plant, Jesse?
Because if we get a lot of dirt in the shot, then that is not soybeans, and we want to take the spectra of soybeans. Preferably, we actually should do a dirt, just so we know what the dirt spectra looks like, or the dry and dead spectra look like. We can do that later.
Why do we want the smaller corns, Petya?
Because we see that it's smaller and the leaves are less green, and so we think that maybe they didn't get enough nitrogen as much as the others.
Fantastic.
For this one, now that I've raised the bar, keep your Stellas about this high to get about the same, similar field of view, like area. All right. Once Lebo's ready, we will go ahead and get started.
What are you gonna name these?
Corn one.
Corn one, got it.
Centered?
Mm-hmm.
Yes?
Yep.
Cool.
Okay, so this is 18. Right here.
Yeah, over there. 18 is their 0.
Okay. 19 is 1.
Closer to the middle.
Sorry, I was just trying to see if it showed.
Right there.
Oh!
Or
Sorry, like
A little farther up.
blended in.
But see, this is what I do. This is my work.